Hello and welcome to week 1, lesson 2, where we're looking at scientific notation. Now, you should have seen scientific notation before, but if not, this video will get you caught back up. I can convert numbers from scientific notation to standard notation and back. So, definition of scientific notation is a number in scientific notation is written as the product of two factors in the form of a times 10 to the n. Now, there's some important things you need to notice here. A has to be between 1 and 10. If it's not in scientific notation. And n has to be an integer, which means a whole number, no decimals. It can be positive. It could also be negative. Okay, so first one here, 2.34 times 10 to the fifth. Well, 10 to the fifth, if I expand that out, is 100,000. 2.34 times 100,000 is 234,000. Okay, now we wouldn't have to do this middle step. What you can do is you can move the decimal positive 5, so it means to the right 5. 1, 2, 3, 4, 5. It adds 3 zeros at the end, which is what you see here. Okay. What about a negative exponent? Well, to make a number smaller, we move the decimal to the left. Okay, so this is going to be 5.69 times 0.01, which ends up being 0.05679. So I move the decimal to the left 2, which puts 1 0 between the decimal and the 5, which is what you see here. How about this one? 17.2 times 10 to the 13th. Hopefully you notice this is not in scientific notation. The 17.2 is bigger than 10. So I can do something with this, but not yet. So right now we're just going to say what's not in scientific notation. All right, so converting large numbers. The current world population, as is from a little while ago, so it's not completely accurate, but you get the picture. It's a very large number. So 7,830,109,813. Well, let's write that in scientific notation. So right now the decimal's after the 3 at the very end. I want the decimal to be between the 7 and the 8 because that would put A, the number in front, between 1 and 10. So I need to put the decimal here. Now, in doing so, I move the decimal 1, 2, 3, 4, 5, 6, 7, 8, 9 spots. So that puts my exponent at positive 9. Okay. Now you might be thinking, oh, I moved the decimal to the left. Shouldn't that make it negative? No, we're taking a big number, okay, which means the exponent should be positive. And that's probably the better way of thinking of it. Don't really think about which way you're moving it. If you have a positive exponent, you have a big number. All right, so if you have a big number, your exponent should be positive. Now this is kind of nasty, so we're going to round this to the nearest hundredth. So 7.83 times 10 to the ninth. This has, we're going to let this have 3 significant digits, the 7, the 8, and the 3. You could also convert small numbers. So right now the decimal's way over here, you can see it. I want it to be between the 3 and the 6. So I'm going to put it there. Now, how many times did I move the decimal? 1, 2, 3, 4, 5, 6, 7. I moved it 7 times. Now I move to the right. A lot of people think, oh, that makes it positive. Well, think about what I just said. A small number should have a negative exponent. And I define a small number to be a number less than 1. And I define a large number to be a number bigger than 10. Why those numbers? You look back at the beginning, scientific notation, the first number is between 1 and 10. So if it's bigger than 10, it's a big number and has a positive exponent. If it's a small number, less than 1, then it should have a negative exponent like it does here. Okay. State whether each number is written in proper scientific notation. If not, then make the needed changes. So this first one. Hopefully you see that it is not in scientific notation because 29.37 is bigger than 10. The decimal needs to be 1 spot over between the 2 and the 9. So I'm going to do that. I'm going to move it over. Now that has an effect on my exponent. Easiest way for me to explain this, the 29.37, I turned 2.937. So I made that number smaller, 29 to 2.9, made that number smaller. So I need to counteract that by making the exponent bigger. By how many times I moved the decimal. So I moved it 1 spot. So the exponent gets bigger by 1. So it becomes 10 to the 15th. Take a look at this one. 0.94 is less than 1, so it's not in scientific notation. I want it to be between the 9 and the 4, but in this case, I made 0.94 bigger. By making it bigger, I need to counteract and make the exponent smaller. -5 minus 1, which gives me -6. Last one, 485 times 10 to the 6th. Again, not scientific notation. 485 is bigger than 10. Right now, the decimal's after the 5. I need to move it 2 spots. So 4.85. And making it smaller by 2, I need to make the exponent bigger by 2. So 6 plus 2, 8. And that concludes lesson 2, scientific notation.